When we learned about vectors the first time, and we learned how to add vectors, I made the point that we're not going to really be adding a whole lot of vectors. What we really care about is subtracting vectors. And that's what we'll talk about now, subtracting vectors. Because that's what we care about. But in order to subtract vectors, you have to know how to add vectors. Just like remember when you were a little kid, you first learn how to add. And once you mastered that, then you learn how to subtract. All right. So here's how you do it. So A minus B is the same thing as A plus a negative B. Now, what's a negative B? Well, if that's B, what do you suppose negative B is? Well, remember, vectors have magnitude and direction. Well, the magnitude is not going to change, so the direction changes. So if that's B, then that is negative B. So all you do is just switch the direction. That's all it is. Okay? So here we go. All right, so A minus B is A plus a negative B. All right, we gotta practice this. All right, so we want A minus B, so here's A. Okay, now minus B is just going to point down. So let's do head to tail. So minus B is going to be something like that. I don't know, something like that. So then, we're adding this vector to that vector, so we just go like that. So A minus B. Okay. All right. You please, everybody stop the video and do this. You have to know how to subtract vectors. You'll see. So everybody do this on your own, please. All right, so I assume that you've done it on your own. So let's do it. So we have A is something like this. Okay, B, same magnitude, just points down. So minus B. So there's minus B. And then just like before, right? Beginning to the end. So A minus B. Okay. All right. Stop your video and do this one, please. All right, let's do it. I assume you've done it on your own. I hope so anyway. So if this is B, then this is A minus B. This is minus B. Minus B. Okay, let's do it. So A is kind of like that. And then we want, I shouldn't have drawn that. Hold on. So A is like that. And then minus B is like that. So A minus B is like that. All right. One more. Now, this is a special one, and you'll see why soon enough. So I haven't been particularly careful with these, but I want you to be really, really careful with this one. So I hope you have a piece of graph paper. That would be best, or just line paper. So here's a horizontal line, and this angle is exactly equal to that angle, and this magnitude is exactly equal to that magnitude. So try to do this one carefully. Do it on your own. So pause your video and do it on your own. All right. You're going to see this again and again, this one. All right, so here's my horizontal line. So I want B minus A. So B is sort of like that. And then, whatever. Then minus A is kind of like that. So beginning to end, A minus B. So the important thing is it points straight up, right? So so it points straight up. B minus A points straight up. All right, let's review components. So here's a question for you. I have vectors x, y, and r. What's the vector equation that relates x, y, and r? So figure that out. That should be easy, right? So vector x plus vector y equals vector r. Okay, what is x in terms of r and theta? So this is something that you just need to know, just like that. You shouldn't have to say, oh, I don't remember. The kids that took trig here at BYU, they have this weird way of remembering the trig functions, Sokotash or something like that. You shouldn't have to do that. You should just know it, all right? So you should just know that x equals r cos theta, all right? You got to know it, okay? And what's y? Y equals r sine theta. I mean, there's nothing wrong with that Sokotash thing or whatever, just to learn it the first time. But what I'm saying is, you've already had a trig class, so you ought to just know this, just bang, just like that. Okay. All right, so like we talked about before, if this is vector A, this is the x component, and this is the y component. And so we can say that vector A, oops, not supposed to use that. So we can say that vector A equals vector AX plus vector AY. So this is the x component, this is the y component. And again, AX, A cosine theta, AY, A sine theta. All right. Let's see. All right, so everybody pause the video and figure this out. Please find the x and y components of this vector. All right, find the x component and find the y component of that vector. All right, I'm assuming you're back. So the x component, you're just going to use this. So x is r, which is 3 whatevers, right? And cosine of 30. All right, and I'll let you figure. Okay. And that's 3 times radical 3 over 2, which is 3 radical 3 over 2. All right, y is r sine theta, which is 3 sine of 30, which is 3 sine of 30 is a half, so you get 3 halves. Okay? Now, please do this. So pause your video and do the same thing. All right? I assume you've done it. It's the same answer, right? Same answers. Who cares? We talked about this before. Who cares where the vector is located? The characteristics, the properties of a vector are magnitude and direction. This has the same magnitude as that one, has the same direction as the other one. So same answers. Okay. All right, let's do some vector algebra. Vector algebra. So here is vector A. Oh, good, it's short. Here's vector A with components AX and AY. Here's vector B, components BX and BY. Now, so what I'm going to say, I'm going to create a new vector, C, and I'm going to have vector C equals A plus B, all right? So will be, all right? So I'm going to add this to this, and I'll do it head to tail. So there it is. So here's A, here's B, so this is C. All right. Now, question I have what is Cx? So what is the x component of C? Well, here's C, and so this is Cx, right? This thing here. Now, what's it made from? Well, here's Ax, right? This here is Ax. This is Bx. So it's pretty obvious that Cx is just Ax plus Bx. Kind of makes sense, right? I mean, if C is A plus B, then it stands to reason that Cx equals Ax plus Bx. All right, same question for the y. So here's Cy. What's that made from? Well, it's made from Ay plus By. So Cy equals Cx plus Cy. Okay? All right. Now, next question. So we have Cx and we have Cy. If I know this and I know this, how can I get the length of C? So you should have learned that in trig, Pythagorean theorem. So the length of C is just Cx squared plus Cy squared square root of. You have to know that for sure. We'll use that all the time. Pythagorean theorem, right? This squared plus that squared is that squared. All right? Something else that we'll use a lot is oftentimes we want to figure out this angle, theta. Okay, so go back to trig. So tangent theta is opposite over adjacent. Okay, what's opposite? Cy. And what's adjacent? Cx. Okay, now that's tangent theta. I don't want tangent theta, I want theta. So how do you go from this to theta? You just take the inverse. So theta is just tan inverse of Cy over Cx. And we'll do that a lot, okay? All right, so you should know all of that because you should have learned it in trig. So this was just a review, hopefully. Okay, now we're going to talk about something called a tilted coordinate system. Now, oh yeah, I forgot to show you that, whatever. Okay, there's Cx, there's Cy, okay. Pretty soon, we're going to be talking about forces. And we'll be doing what's called equilibrium problems. Okay, equilibrium just means that the sum of the forces equals 0. Don't worry about this now too much, because we're going to be doing it later on. So for this particular situation, this is the object. Remember I talked about the particle model? So this might be a car, who cares what this is? It's supposed to be a dot, but oh well. So it's a particle, right? We represent it as a particle. And there are 4 forces acting on it. F, whatever that is, N, whatever that is, T, whatever that is, and W, whatever that is. We'll learn all about that later. Okay, so what we're saying is that this object is in equilibrium. That means that the sum of the forces acting on it are 0. Now what we generally do, there's X forces and there's Y forces, so we split it up. So what we really say is that the sum of the forces equals 0. Well, that's great, but we got to split it up. So we say the sum of the X forces equals 0. Okay? So what does that mean? Well, what does that mean? It means that the tension, which is to the right, minus F, which is to the left, has to equal 0. What does that mean? That just means T equals F, right? Okay, let's do the Y. So the sum of the Y forces equals 0. So we're saying up is positive, down is negative. So that means N minus W equals 0. So N equals W. All right, Not so bad, right? Now, this was easy because all of the forces were along the coordinate axes. We didn't have to do any trig. Well, guess what? Real life's not so easy. So, we want to do something like this. So now, here's an inclined plane. Just pretend it's a piece of wood or something, you know, I don't know. And maybe we're dragging something up that piece of wood or something. Okay, so now, you know, here's our regular coordinate system, right, that we used before, you know, our normal XY coordinate system. Okay, but now this doesn't lie along this, you know, here, that's not along the X or the Y. This is not, this is not. This is the only one that's along one of the coordinate axes. So if we want to do something similar to this, you know, we have to resolve this one into an X piece and a Y piece, this one into a X piece and a Y piece, this one into an X piece and a Y piece. That's a lot of work. In fact, that's too much work. I don't want to do that. Why would I want to do all that when there's an easier way to do it? Okay, the easier way is just take this coordinate system, you know, this coordinate system, and just tilt it, all right? Just rotate it, whoosh, you know? And so there you go. So now this is the new x-axis, and this is the new y-axis. And now we have three vectors that are along the coordinate axes. This is the only one that's not. So we only have one to resolve. So your choice. You want to resolve 3 or 1? Well, hopefully you'll choose 1, right? You also want to save work because then there's less probability of making a mistake. Okay, so that's what we're going to learn. So we want to always learn how to, well, we want to learn how to do this tilting of a coordinate system. Okay? All right. Now, yeah, there's something incredibly important. When we resolve this vector here, we're going to have to know what this angle is, right? And so here's the answer. So this angle is always equal to this angle. So you notice that this angle here is the angle between the new y-axis and this w. This is the weight vector, by the way. Okay, so it's this angle between the new y-axis and the vector. Now you can prove that using high school geometry, and if you feel like it, go for it. I'm not going to prove it in class though, but you need to know this for sure. So, all right. Okay, so what we want to do, okay, yeah, all right, so again, what we want to do is we want to resolve this weight vector. And so this is the y-axis, so this is going to be the y component. Okay, this is the x-axis, so this will be the x component, right? All right, so what we want to talk about now is we want to figure those out. Okay, so what is the y component? Just the magnitude. I don't care about direction. We'll worry about direction later. So what is this y component? So remember, all we know is this w, right? So what's the y component? Well, just the magnitude. Well, this is, you know, this is adjacent, correct? So this is a cosine. So that just the magnitude, so wy equals w cos theta. Now, what's this wx? Well, that's opposite to the angle, so that's sine. So wx, just the magnitude, equals w sine theta. All right? Now, sometimes this freaks people out. So, I mean, here, let's go back to this, ay, ax, theta. So some people, you know, they think like robots. Don't do that. And so some people, you know, so ax is a cos theta, ay is a sine theta. And so some people, if there's an x component, there has to be a cosine. If there's a y component, there has to be a sine. It's total garbage, all right? You have to analyze the situation, right? So there's nothing to memorize, you know? So here's a y component. by golly, it has a y component has a cosine. The x component has a sine, okay? So don't be robots. All right. Okay, so let's analyze this problem now, okay? So again, equilibrium. Equilibrium means that the sum of the forces equals 0. And so the first thing we do is the sum of the x forces. All right, so what is the sum of the x forces? Well, we have an x force there, we have an x force there, but now we have another x force, right? Because we tilted. Now we have an x force there as well. And remember, that way's plus, that way's minus. All right, so the sum of the x forces, t to the right, and fk to the left, and wx to the left, and that equals 0. And let's just say we wanted to solve for t for whatever reason. So therefore, to solve for t, so t would equal fk plus wx. All right, let's do the y. Sum of the y forces. Okay, remember, that's positive, that's negative. So the n, right? So we have an n, and now we have this guy. So n minus wy. Okay, and that equals 0. So n equals wy. And again, all right, and yet, again, you know, yeah, maybe I should do that. Hold on. So this would actually be, so t equals fk plus wx, which is w sine theta. And here we have n equals wy, which is w cos theta. Okay? So we'll be doing that all the time. So that's why I keep saying you have to know your trig just like that. There's no thinking involved. You're going to know it. Now, here's something. We'll prove this later. But it's just something that you should know now for when you start doing your homework problems. So this is basically, you know, if I drop something, the acceleration is just, you know, g, right? 9.8 meters per second squared down. But what if something is sliding down a slant? Well, it's obviously going to be less than that. And so here it is. So it's g sine theta. G sine theta. So A is plus or minus g sine theta. Now what's the deal with a plus or minus? Well, it depends on your coordinate system, right? It depends if you want down plus or down minus. But anyway, let's see if this makes some sense. Okay, so let's just say I drop something. So if I drop it, you know, what's the angle? Well, if I drop something, this angle is 90. All right, so you drop something, theta equals 90 degrees. What's the sine of theta? 1, right? Sine of 90 is 1. That's what I meant to say, right? Sine of 90 is 1. So therefore, A would just be plus or minus g sine of 90, which is 1, right? So, right, sine of 90 is 1, so it would just be plus or minus g. On the other hand, let's say we have something going like this, right? So it's completely flat. So here I put a box or something, right? Now, if I just let go and it's completely flat, what's the acceleration going to be? 0, right? It's not going to accelerate at all. Okay, well, what's the angle? So if this is completely horizontal, whoop, the angle is 0. What's sine of 0? 0, right? And so this would, right? So sine of 0 would be 0, so A would be 0. All I'm saying is that formula makes sense and it's correct, and we'll prove it later on. Let's see. Let's quit right now. You know, that's enough.